Well, it's day 4 for programming, and today we're going to finally take a look at how you can get your code to make decisions while the program is actually running. So depending on what the user does or what situations are happening, you'll actually have your program do different things depending on various conditions that we can test. So up until this point, we've only been doing sequence, where things have all been in an order, and now we're going to start to do some selection, where based on some condition we'll go one way with the code or another way. So sequence is what we've been doing up to now, and that's just one command after another, and every single command is always executed. But now we're going to do something that looks more like this. We're going to get to a decision point where we're going to do a little test, and then based on the results of the test, we'll either go one way and do one section of code, or we'll go in a different direction, do a different section of code. The first type of structure we're going to take a look at is just a simple if statement, and there's going to be a little test that we'll check out, and if that condition is true, then we're going to do a particular little chunk of code, and if it's false, we're going to completely skip it and then resume the execution of the program after that. So if the condition is false, we won't do anything at all, but if it's true, then there's one particular thing that we'll do. And so here's some code that actually does that. Really simple here. We're just going to ask somebody if they have a cat or a dog, and then we'll store that answer, assuming this is fully declared as a string, and we'll store that answer as an animal type. And it's the last line that you'll want to take a look at. So we start off with this word if, and that tells the compiler that the next section of code may or may not happen. And then there's a test right here where we can actually see what we're actually evaluating to decide whether we'll do the code or not. So only if they've typed in cat, we're going to actually go and execute this cout command. But it'll have to be the word cat for animal type in order for that to happen. And one thing to notice is this double equal sign. When we actually test things for equality to see if it's a true statement or not, a single equal sign doesn't work. That's actually for assigning variables. Here we want to test and see whether or not it's a cat, so we use a double equal sign. Different way to do this: if you need to actually print off more than one line, if you need to have more than one line execute, if the if statement is true, then the classic if statement doesn't work very well. It only does one thing after it. But by actually starting off this little code block here with some brackets, the opening bracket and the close bracket says, all right, this is one thing. Everything from here to here is the one thing that you need to do, only if they've typed in dog for their animal type. So it'll actually do both of those cout commands, but only if they've got a dog. And then whether they've got a dog or not, the execution of the code will just resume right after the if command. Another option that you can use is an else structure. So sometimes you're going to do a test, and if the test is true, we will do one thing, and if the test is false, we will for sure do something else, and then the code will just resume after that. So here's a little example of code that would do exactly that. We're going to ask people what their favorite number is from 1 to 10, and then we'll store that as an integer. And then there's this section of code that's going to look and see whether or not they've typed in the number 4 for their favorite integer. So we do this test here in the if. We're going to go and see whether their favorite integer is 4. And if it is 4, that is the only way that we'll do this section of code. And that's a code block because there's a couple of things that we're going to try to do there. But only if they've typed in 4 will that happen. And then if they haven't, then we will for sure do this section of code. And the only way that you'll do that section of code is if they have not typed in a 4. And then regardless of whether they've typed in a 4 or not, the execution of the program will continue with the next line after that else structure. You can actually take ifs and put them inside other ifs. So this is called nesting ifs. And it can make the program look a little bit complicated, but indenting can really help your eyes try to figure out exactly what's going on. So here's some code that actually does that. At the very beginning here, we're just going to interact with the user a little bit, and we're just going to ask them if they have a cat or a dog. So we'll store that as animal type, and then we're going to ask them, well, how old is your animal type, whatever that might be, that cat or dog, and then we're going to store that as the age of the animal. And then we get into the whole if section, which is here. And there's actually a set of ifs inside the original if. So right here at the beginning, we're going to go and do a test to see if they have a cat. And only if you have typed in cat will this section of code happen. And this section of code happens to have another if in there. It's going to test and see whether or not the animal is old or not. So if it's greater than 2, then we can say, oh, well, you have a happy cat. The only way that you can get to this section of code is if they've got a cat. So we can give a message back that's appropriate for them having a cat. But if their animal is not greater than 2, if it's 2 or less, then we're going to go and do this else structure right here. Then we'll actually go say, oh, well, you have a young kitten. But again, only if they have a cat will we execute that section of code. And then there's the else. Okay, so all of this section of code is if they don't have a cat. So if they are into this section, then they're going to have a dog. And then we can do another if in there. And the next test is to see whether it's bigger than 3. And we will do this cout only if the age is bigger than 3. And the last else would be if they're definitely owning a dog, and if the dog is not going to be greater than 3, so they've got some puppy that might eat their homework, and then we can display a little message for that. So it's totally okay to put an if inside another if. And indenting your code like this really, really helps. It allows you to see that, oh, that whole section is special because it's inside the first if. And this section here is special, it's inside the second if. So you can only get there if both of the ifs are true. As you're doing these if statements, you're going to have to do these tests all the time. And if you look back, they're actually just sitting here in brackets right after the word if. And so far we've seen this one that has the double equal sign. Well, there are a few others to be aware of. If you want to test and see if something is not equal to something, then it goes with the exclamation mark and equal sign. And you can do greater than or equal to by just putting the two one after another in that order. And you could also group those logical tests together. So a double and like that is actually equivalent mathematically to the word and, which would mean that both conditions right here, x equaling y, and the condition m equaling n, both of them would have to be true in order for that full test to be true. And two vertical lines side by side is the equivalent mathematically of the word or. And so if you wanted to do a if command where if this was true or if the m was less than n, if either of those was good enough, then that's how you would set that up. Sometimes you're going to have a whole bunch of if-else's one after another, and as you look at it as a flowchart, it might look something like this. You know, if a particular test is true, go and do something. If not, test again to see if something else is true. If not, go and test again, and that could continue for quite some time. And the usual way of laying that out would probably look something like this. So here's a little section of code that would check to see what kind of grade some student has. We're going to, at the beginning, just ask them what their percentage is. So this is just a little interaction with the user here. And then we're going to get into a little if-else-if structure. So the first if is going to test to see whether or not they have an A, if their percentage is greater than or equal to 86. And then this cout will only happen if their percentage is greater than or equal to 86. But what if it wasn't? What if their percentage is something lower than that? Well, that's how you would get into this section right here. And it's okay just to put this if right beside the else. And so we know that they're not getting an A, but we might want to check to see whether they have a B. So we're going to do another test here. And this one actually combines a couple of tests together. If their percent is greater than or equal to 73, and at the same time their percentage is less than or equal to 86, then we know that they've got a B, and we can go and do cout that would actually indicate that, yep, they've got a B. And we can continue that game all the way down until the very end, and then this last else at the end is only going to happen if the first sections there didn't occur at all, and so that's kind of our default. Technically, you probably don't have to have this test of whether or not their percentage is less than 86 for that B section of code, because the only way to get to this particular part of the code right in here is if they didn't have a grade that was an A. But in any case, if you have a whole bunch of ifs where it's like one case or another, you can just use that else if structure all the way down. And that concludes this day of programming.